You know that feeling, right? You're cruising at 35,000 feet, scrolling through Instagram, and it hits you. How is this even possible? It seriously feels like magic, sending emails or streaming Netflix from a metal tube blasting through the sky. Well, it's not exactly magic, but it is an absolute marvel of engineering. So let's pull back the curtain and figure out how it all works.
I mean, this is the fundamental question, isn't it? Getting a signal when you're standing still is one thing. We do that all day. But trying to hold on to a stable, high-speed connection with something moving as fast as a commercial jet, that is a whole different ballgame. Seriously, how do you even catch a signal that's moving that fast?
Let's just let that number sink in for a second. 600 miles per hour. That is the heart of the problem engineers had to crack. It's like playing the most extreme game of technological catch you can imagine, across huge distances. And the way they figured it out, it's just brilliantly clever. So to solve this massive challenge, engineers came up with two main systems that work in, believe it or not, completely opposite ways. One of them looks down to the ground, and the other one looks up to the stars. Let's start with the first one.
Okay, so our first method is called air-to-ground, or ATG for short. The easiest way to think about this is like the cell connection on your phone, just, supercharged for a plane. The whole idea is to keep a constant link with a network of towers down on the ground.
So the really crucial part here is where they stick the antennas. With an AT&G system, they're mounted on the belly of the plane, pointing straight down. This lets them talk to a special network of cell towers, towers that are specifically designed to shoot their signals up into the sky, not out to the sides like your regular cell tower. And here's how that works in practice. As the plane is just zipping along, its systems are doing this constant, super fast digital handoff. Before it loses the signal from one tower, it's already locked onto the next one in the chain. It's basically a seamless relay race happening at hundreds of miles per hour, making sure you get that continuous stream of data. But, and this is a big but, here's the catch with ATG. No towers, no signal. Simple as that. So this system works great for flights over land, coast to coast. But the second you fly out over the ocean or a huge remote area with no towers, poof, the connection is gone. And that big limitation leads us right into our second, much more global solution. All right, so to solve that whole flying over the ocean problem, we have to look up, way up. This is where satellite connectivity comes in. It's the reason you can make a video call or watch live TV on a flight from New York to London. Instead of talking to towers down below, the plane starts talking to satellites orbiting thousands and thousands of miles above the Earth.
Okay, check this out, because this shows you the entire journey your data takes. You've got an antenna, but this time it's on top of the plane. It sends a signal way up to a satellite, that's the space segment. That satellite then bounces the signal all the way back down to a station on Earth, the ground segment, which is plugged into the regular internet. And this whole round trip, it happens in just a fraction of a second. It's wild.
But here's the thing, not all satellites are created equal. For a long, long time, we relied on what are called geostationary or geosatellites. These guys are way out there, over 22,000 miles away. That huge distance creates a noticeable delay, what we call latency. But the real game changer lately has been the rise of low Earth orbit, or LEO constellations. They orbit so much closer to Earth, which slashes that delay and makes the connection feel way snappier, a lot more like what you're used to at home. And it gets even more detailed. Within satellite tech, you've got different frequency bands, and each one has its pros and cons. Think of L-band as the super reliable workhorse. It's not fast, but it always gets the job done for basic stuff. Then you have Ku-band, which is kind of the established middle ground. And then there's K-band. That's the high-performance one, giving you the fastest speeds you need for video streaming, but it can be a little more sensitive to things getting in the way. Okay, so you're probably thinking, if this tech is so amazing, why does my Wi-Fi sometimes, suck? And that's a fair question. The truth is, there are some pretty serious real-world challenges, both physical and logistical, that can make that connection feel a little bumpy. Let's get into why that happens. First up, we've got a seriously cool physics problem called the Doppler shift. You know exactly what this is. Think about an ambulance siren. It sounds higher pitched as it races toward you, and then the pitch drops as it passes and it moves away, right? Well, the plane's incredible speed does the exact same thing to the Wi-Fi signal's frequency. The systems on the plane have to constantly, in real time, adjust for this shift to keep the connection from just falling apart. Next up is just the simple reality of sharing.
It's not like your Wi-Fi at home where maybe a few people are using it. On a plane, you've got, what, 300 people all sharing one single connection to the outside world. So yeah, if a handful of people all decide to start streaming 4K movies at the exact same time, everyone else on that flight is definitely going to feel the slowdown.
And finally, you can't forget about good old Mother Nature. Especially for those satellite connections, something as simple as a heavy rainstorm can cause a problem called rain fade. The water and humidity in the atmosphere can literally absorb and weaken the satellite signal before it even gets to the plane. It's like trying to shout through a thick fog. So, with all these challenges, you might wonder what's next. Well, the evolution of this technology has been unbelievably fast. And believe me, the future of the connected cabin looks even more exciting. I mean, just take a second to look at this progress. In 1921, the big deal was projecting a single silent movie on a wall. Fast forward to 2001, and we sent the first email from a plane. Now, just a couple of decades later, we're talking about streaming high-def movies through these amazing LEO satellite networks. The pace of change is it's staggering.
And the future? It's all about completely erasing that line between being on the ground and being in the air. The big goal is to give you that at-home experience. We're talking gate-to-gate connectivity, so you never have to disconnect. We're seeing AI starting to personalize your entertainment. The systems themselves are getting lighter to be more eco-friendly, and there's this huge move toward just letting you use your own device for everything.
Which really leaves us with this one big question to think about. As this connection gets faster, more reliable, and just seamlessly integrated into the cabin, are we heading for a future where flying feels no different than just chilling in your living room? It's a pretty cool thing to imagine, and honestly, the technology to make that happen is getting here faster than you might think.